Find the derivative of y equals 5/4 x to the 2/3. If you're just finding the derivative of a polynomial and you have a bunch of, exponents, variables, coefficients here and there, that requires only the power rule. Now, this is what the power rule says. I'll just quick write out the definition. d dx means you take the derivative of, some constant, I'll call a, x to the n power. This is what I have here. A would be 5/4, x is x, n is that exponent right there. What you do is you take that n, you drop it down, you multiply it to the coefficient, keep x, and subtract 1 from n. That is the power rule. Again, bring the exponent down, multiply it to that, subtract 1 from there. So let's get rid of this. Okay, let's get rid of this now that I know that. What I'm going to do is y prime, or I could call it dy dx if I wanted to. I'm going to take that 2/3, I'm going to bring it down, multiply it to the 5/4 that's already there. X is x, and 2/3 I'm going to subtract 1 from. All right, so a lot of cleanup on this problem, but, that's fine. It's part of the job. 2 times 5 is 10. 3 times 4 is 12. I can simplify that. X to the 2/3 minus 1. That's the same thing as saying 2/3 minus 3/3 for those of you who hate fractions. All right, so let me clean all this stuff up a little bit. That gives me 10 over 12 is 5/6. X is x. 2/3 minus 3/3 is negative 1/3. So the way I will wrap this problem up, and I'll actually take 2 steps to wrap it up, is a negative exponent drops x to the other side of a fraction bar. Right now, it's on the invisible top of a fraction bar, even though, there's no fraction bar. I could put over 1 if I wanted to. Now I have it on the bottom. So 5 remains in the numerator, 6 in the denominator, x to the drop it down and make it positive 1/3. Now, you can leave it like that if you want to, but an exponent of 1/3 also gives you the cubed root, so this is the other way that we could write this out. Either of these is perfectly fine, either of these is simplified, and that's my guy.